Everybody, welcome back from break. I kind of wanted to get us back to level set. We are done with chapter 5, and I'm not sure I specifically mentioned this, so I actually moved it. There is a chapter 5 quiz that is due. It was due tonight at midnight, but I don't think I mentioned it in class, did I? Perhaps I didn't. So I moved it to Friday, this Friday at midnight, okay? So it's out here on Blackboard. We're using Blackboard now. And Chapter 5 quiz may be taken up to 5 times. And we're moving on today to Chapter 6. So after Chapter 6, we're going to have our second exam. So our second exam will be Chapters 4, 5, and 6. Okay? Hardware, software, data, databases. And then Chapter 6 is what's called the cloud and networking. So still kind of on the computer side of things. I graded probably about half of your access assignments. They were fairly good. I have some time this morning. I'll probably try to grade the rest of those later. So any questions about where we're at in the course? Okay, then let's move on to Chapter 6. And you know, I like Chapter 6 because it talks about something, real important, kind of transformed the business industry over the last 5 or 6 years. Okay? We're going to talk about, in Chapter 6, the cloud and networking. And we talked a little bit about this earlier when we talked about thin clients. But if you think about it, up until about 2010, if you had some kind of application, like an organizational application, well, then you had a server located at your facility that people connected to and ran that application. And in about 2010, it became more and more prevalent to do things in the cloud. And we've used that term before. What does the term the cloud mean? What does the cloud mean? What does that refer to? And we're going to define that a little clearer today, but what is the cloud? Cody, what's the cloud? If I said that's hosted in the cloud, what does that mean to you?
It's like storage somewhere.
Okay, right. It is nebulously defined because we don't know where it's at. You said somewhere. I like that. Okay, so the cloud is on the internet somewhere. We don't exactly know where it is. So when we run something in the cloud, what does that mean? So we're an organization. That's what we're concerned with. Where our applications run. We're going to talk about running things in the cloud, and here's the definition that we're going to use for the cloud. Okay, the cloud is an elastic leasing of whole computer resources via the internet. So there's 3 key words in that definition for the cloud. First off, elastic. What do you think that means? We know what elastic means. What do you mean about elastic leasing? What does that mean? What do you think what's the key there with elastic leasing? Anyone? Go ahead.
Expandable.
Okay. So one of the things, 2 terms that we talk about in MIS or the computer industry is capacity and scalability. What is capacity? Now, sometimes you guys might get a lot of tests and you're like, I don't have the capacity to do that, right? Because, I don't have the hours in my day to get all that done, right? Capacity is, we want to put 100 people in here. This room can't fit 100 people. It doesn't have the capacity to fit 100 people. Scalability is the ability to change that capacity easily, right? If it's a scalable solution, meaning you can go up and down pretty easily, elastically. And that's one of the hallmarks of the cloud. So the book uses an example, and I think it's a pretty good example. Let's say we run a video banner ad, right? We do maybe we do a TV commercial, and we're trying to drive traffic to our website. Okay, well, we don't know if that's going to be a successful advertisement or not. We don't know if we're going to get 5 clicks. We don't know if the damn thing is going to go viral, or we're going to get 5 million clicks, right? Well, if I had to have an in-house server at my place, I would have to say, well, that in-house server can only handle so much, right? And if I wanted to handle it big, well, that's very wasteful because maybe I only get 5 clicks and I have this huge server that does nothing. And if I go small or medium and it goes viral, it goes, we get a lot of clicks, well, we can't handle the capacity and it goes down. And maybe you remember things like this where, I don't know, where someone didn't plan for the amount of traffic that they were going to have and their website was down. So they missed the golden opportunity. You guys ever hear of that? Okay. So what the cloud provides us is because the resources we're using aren't controlled by one physical device, we're kind of going out to the cloud and saying, Amazon or Google, we want to use 10 servers, and we can easily change that by paying more to use 20 servers or 50 servers. We can do that. So it's very easily changed. Automatically adjust for unpredictable demand. And as part of that, it limits our financial risk. We only pay for what we use. If we're using one server, hey, we only pay for one server. If things go wild and we use 1,000 servers, well, we're going to pay more, but hey, that's good. That's a good problem to have, right? Another way to look at this is, when you drive on the highway and you see the giant drainage pipes. You guys know what I mean? Like the giant big concrete drainage pipes. You know what I'm talking about? They're like I could crawl through them. They're that big. Usually, what's going through there? Like how much water is going through there? Typically like a trickle, right? So why is that pipe so damn big? Okay, they're built for the government. They build for what they call once in 100-year rainstorm. That's the size that they have, right? So they have to. It's kind of wasteful. You put in pipes this big, and only once out of 100 years do you really need a pipe that big, right? Well, when we host things in the cloud, it's a little different, right? If we only need a little pipe, it's a little pipe. If we need a big pipe, it's a big pipe, right? It can be elastic. It can be scalable very, very quickly. That's one of the advantages of the cloud versus having my own server. It's not easy for me to add another server, another 10 servers, 1,000 servers. But when we're in the cloud, hell, we just say we're going to use more. And the reason for that we can do that is the second word that's very important in this definition is it's pooled. Okay. So Amazon, Google, all these providers have these huge, we talked about these huge server farms, right? And basically, through virtualization, we talked about virtualization in chapter 4, they can say, well, now virtually you have 1 machine, virtually you have 10 machines, and virtually you have 1,000 machines, just like that, right? They're pooled resources. So they don't care if you're only using 1 or 100 because, if they're pooling it and they're saying now, John Miko can use this, and this other customer can use these things. They're pooled. Same physical hardware. And when we have more and more of this stuff, right, when we have all, we get what we call economies of scale, okay? Economies of scale because, it's not one server, it's millions or thousands of servers, so they can be accessed. The last one is via the internet, and we're going to talk a little bit about the internet and networking technology a little bit later. But the internet is how we access the cloud. And before the internet became prevalent, became stable, the bandwidth became appropriate, some of these things weren't possible. Another kind of example that I'll give you is why organizations are moving to the cloud. At one point, organizations, including St. Francis, generated their own electricity. So we use electricity at St. Francis, obviously, right? So we had over at, they call it, where the arts are, what do they call that? You guys know what they call that? Where the fine arts stuff is? They call it the boiler house. Why? Why do they call it the boiler house? Yeah, they used to have men in there shoveling coal into a fire that drove turbines that generate electricity for St. Francis, right? And a lot of organizations did that. They made their own electricity. Like if you're Westinghouse, you make your own electricity. If you're St. Francis, you make your own electricity. Mount Aloysius, you made your own electricity. That was, 50, 60 years ago, that was the standard, right? Where do we get our electricity now? Where do you get your electricity at home? What's Cadillac? And I don't know if you've ever seen that. It says, you know, Penelec is your provider, but all electricity comes from where? What do they call it? The grid, right? You just kind of tie into the grid. That is a central resource, and that's what we're kind of talking about with the cloud. You know, instead of me having my own servers, we go out to the cloud and we go to the central resource, and that's why we enjoy, economies of scale, because if you think about it, Penelec or whoever's producing that electricity doesn't have two men shoveling coal into a boiler house, right? They have gargantuan plants, and they can produce that electricity much cheaper because that is their sole function. Our sole function isn't generating electricity. Our sole function is what? Education, right? So why should we focus on that? Let's go to the experts and that central resource, and that's what we're talking about with the cloud. Why do we need to, let me hold off on that. Okay, so I've told you that the cloud is where a lot of organizations have gone. Okay, a lot of organizations have gone. Give me some reasons. So we're going to talk about the cloud, like hosting an application in the cloud versus in-house. You guys know what that means? I know I just explained the cloud, but do you know what cloud versus in-house means? What do you think that means? How about email? Let's talk about email in the cloud versus in-house. What do you think that means? Go ahead.
With the cloud, you would have like a certain amount of, or pretty much unlimited amount of storage for email, and then like in-house.
So give me an example of cloud email. Email is cloud email, meaning, you know, I have a Gmail account, you know, I don't have a server at home that has, you know, I'm not Hillary Clinton, I don't have a server at home that has my email on it, right? I go to the cloud. I don't know where the hell my email is stored, but they're somewhere in the cloud, yes? Okay. How about St. Francis? What do we use for an email solution? What do we use? We use Novell GroupWise, right? GroupWise is an example of an in-house solution, meaning somewhere, I think it's in SCOTUS Hall, on the second floor of SCOTUS Hall, there's something called a server room, right? And there's a computer or several computers that have all our emails stored on that. So when I log in, whether I'm logging in from home or on campus, it's going to the internet, going to that server. We maintain that server, we back it up. If it breaks, it's our fault, right? If something goes wrong, if it crashes, okay, it goes wrong, that's a bad thing, okay? So those are the two options. This was kind of mainstream up until 2010, and then people started moving their applications to the cloud. So there must be reasons why. What are some reasons why that became preferred modality for organizations? Why? Give me some reasons. We're going to go through those reasons, but I want you guys, before we go through the slides, tell me some reasons why. Okay, so first off, we talked about economies of scale, yes? So Google has thousands and thousands of servers, right? So they enjoy economies of scale. So virtually, if you sign up for a Gmail account, they tell you how much space you have. They're like, I don't know, they give you a lot of space, more than you can use, right? It's like 6, 7, 8 gigabytes, something like that, or yeah, it's a lot of space. It's cheaper, yes? Much cheaper. Gmail is free, right? So it's much cheaper because they enjoy those economies of scale, because Moore's law has driven down the performance ratio of so many things, and we have all these machines together. You know, it's a lot more inexpensive. What else? That's good. What else? What else? What else? Come on, what else?
It's easier.
Go ahead.
It's easier for the company.
What do you mean by easier for the company? Go ahead, give me, why? Why do you mean easier? It is, you're right,
They
why?
don't have to like maintain the servers.
Okay, very good. So we have to, our intent here is what? Our main goal at St. Francis University is this, educating students, right? We're not an IT company, but we have an IT department, yes? And there's a server, and someone has to back up that server, and someone has to make sure it's running the most current release of the operating software, and make sure that, you know, the hard drives are functioning properly, yes? So we have to maintain that. You know, if we host Gmail, Well, who maintains that? Do we? No. Google takes care of that for us, right? And who do you have more faith in? I'm nothing against our IT services, but who do you have more faith in? Google's IT people, who is an IT company, or our IT people? I don't know. I think I have more faith in Google, right? I do. Okay, so it tends to be easier. What else? What else? What else? Very good. What else?
Could stuff in the cloud be automatically backed up?
Okay, because it's professionally maintained, yeah, I'm not worried about who's backing up my Gmail, right? I'm not worried about that. It's out there. It's professionally maintained. So that's true. What else? What else? Come on, you guys. Go ahead, Jordan.
It'd be easier to access too.
Okay, so a couple things, because we have these, it's a very scalable, very a pooled resource. So Google, anyone, Amazon, who companies into this, they have server farms located all over, right? So they basically have redundant processing as well. So if there's a fire in SCOTUS Hall, let's God forbid there's a fire in SCOTUS Hall, and that server is destroyed, you're going to lose email. If there's maybe a fire in the wing of one of the Googleplex's server farms, well, it doesn't matter because they have redundant processing. They'll simply move that stuff over to another server. It's called RAID processing. They have like a duplicate of that data. So that's also true. You're right. What else? What else? All right, let's go through. You guys got many of these. So if we look at the positives, okay, how about a negative? Why might we say, let's before I look at that, why might I say, I don't care, I know the cloud's cheaper, I know I don't have to maintain things, I know it's professionally maintained, I know people can access it from further, from anywhere. Why might I still say I want to do in-house hosting? Tim?
Could you be more vulnerable to hacking and stuff like that?
Okay, so one thing is, if I put my data in the cloud, I really don't know where it's at, do I? I really don't know if it's in Utah, if it's in Mexico. The actual data has to reside in a server somewhere, yes? And when we look at that data, we're going over the internet, right? We have security, and we're going to talk about how the internet works. But if I'm connecting to data somewhere in Utah that resides in Utah, well, I'm going through a bunch of machines, a bunch of networks. I can't control that, right? I can't control that. Some agencies, some organizations have to, like if they have financial data or maybe medical data, they have to have control of their data. They have to know where it is. They have to back it up by government regulation. So you're right. That is a positive with in-house hosting. So the cloud, let's look at the positives. Small capital requirements. Right now, you and I can go out and we could go to Amazon. They have Amazon Web Services, Elastic Computing. You can go out and say right now, I want a server that has 5 terabytes, and I'll sign a contract for $5 a month or something like that. So you don't have to invest in a big server, right? Small capital requirements. Speedy development, superior flexibility and adaptability for growing or fluctuating demand, something we call scalability. Known cost structure. There's a cost structure that tells you if you want to go use this, it's this much dollars. Possibly best of breed security, disaster preparedness. That's talking about, we have experts, right? So we have experts maintained that are IT experts. They're going to have best of breed security, disaster preparedness, no obsolescence, because I'm not investing in a server. I'm letting the company do that, right? I'm not investing, think about the electricity example. If my turbine doesn't work anymore, is obsolete, I don't have to buy a new turbine. We let the electric company worry about generating electricity, right? We just pay them for that service. Industry-wide economies of scale, hence cheaper. In-house, the positives, controlled data location, I know where it's at. In-depth visibility of security and disaster preparedness. I know it's backed up because I'm the one doing it, right? We lost, and by the way, anyone on campus Monday, Tuesday? What happened on Monday? Was it Monday? It was Monday, Kate, right?
Yes, there was no internet.
Okay. So, do you know why? Does anyone know why?
I've heard 2 different things. I heard that was switching to something, and then I heard that there was a crash.
Yeah, the second is the right. So So our internet service provider at St. Francis University, and we'll talk about internet service providers, is who? Do you guys know who it is? It is Comcast, right? And Comcast has, they have like high-speed fiber optic cables that actually connect our campus to the internet backbone, okay? And apparently there was some kind of accident. I can't remember what the road was, but it was like a physical car wreck that took out one of those, like severed. What was that?
It was in Evansburg.
It was in Evansburg?
Right up the street from ours.
Yeah, so, okay. At the six-pack place?
Yeah.
Are they coming from the six-pack place?
Probably.
Yeah, okay. So anyways, that's what occurred. So that one, believe it or not, was not really our fault. But because the connection to our servers, so our servers, if you wanted to access webmail from home, I couldn't access webmail from home because why? Because the connection to our server on the internet was dead, right? So even though our server was fine functioning in SCOTUS Hall, that connection was severed. So if you're on campus, I couldn't get it, right? I could not get it. Now, if you're on campus, you could access email. Could you access your email?
At some point, and at some
Okay.
points
All right. So there was an actual, you should have been able to, I'm not sure why you weren't, but when you were using our network, you should have been able to. If you're using through the internet, you shouldn't have been able to. You don't remember? Okay. But if we think about it, on Monday, did your Gmail work? Yeah, it worked, right? Because think about it, we have one connection to the internet. St. Francis, we have one connection to the internet, it's Comcast. That thing was down, we're down, right? If we're Google, you know they're not putting all their eggs in one basket, right? They're Google. If they have an interruption at all, it makes national news, right? If Gmail was down for 5 minutes, and it's happened, if you Google like Gmail down, it makes national news. It's a big damn thing. Our email's down, I'll just walk over and talk to this person, right? So it's kind of a different level of uptime. Cloud, some of the negatives, dependency on vendor, loss of control over data location, we kind of talked about that. Little visibility through security and disaster preparedness, we have to kind of trust them. In-house, the negative, significant capital required, significant development effort, annual maintenance costs, ongoing support costs, staff and trained personnel, increased management requirements, difficult to accommodate fluctuating demand, cost uncertainties, and obsolescence. Okay, so all those things are a little bit different. By the way, if we think about cloud versus in-house, you guys were part of a kind of a beta test group. We're using Blackboard for our course management system right now. It is, there's versions of it that are in the cloud, but we're running Blackboard on a server at St. Francis University. So it's an in-house solution. So when you guys connect to courses.francis.edu, it's connecting to a server that sits in SCOTUS Hall. We have already said as an organization that our next course management solution is going to be in the cloud, okay? Because we don't want to maintain that server. We don't want to make an investment in that server. It's getting out of date. We know that is the future. So whatever our new course management system is, it's going to be in the cloud. And by the way, I don't know if you know this or not, but it's already been decided it's not going to be Blackboard. So starting in June of 2017, any courses that start June 2017 or after are not going to be Blackboard anymore. It's going to be one of two. The one we use, which was Brightspace, this Desire to Learn, and the other one is called Canvas, I believe. What happened, and this is kind of a nice business example, is Blackboard at one point had, I think, about 75% of the market share of all universities, all colleges, and all universities. So they bought like some of their competitors and became bigger, yes? And what happens sometimes when organizations become bigger? And they have like they enjoy large market share. What happens to the organization? Yeah.
They get like stagnant.
Yeah, they get stagnant, they get complacent, they start pricing like monopoly. So the two that we looked at, maybe I didn't have the best implementation of that. I know I didn't because I didn't know how to do it, so I just kind of winged it. But they have a lot more features and functions than Blackboard, and they're cheaper, right? because they're more like, they're smaller, they're more agile, they're like, you know, they're pecking at Blackboard's market share, which I think is now down to like 40%, right? Because they're just destroying them, right? Slowly destroying them. And that happens a lot of times in business world. You don't want to be what they call like the big, lumbering, slow giant. That's what happens a lot of times when organizations get big and they get fat and happy. You know what I'm saying? It happens with humans as well. Okay, so let's go forward. Okay, so this is the cloud. You know, the cloud makes a lot of sense. We're going to talk now about kind of the infrastructure that makes the cloud possible, right? We know, hey, it's out there somewhere on the internet, and what makes it possible? So we're going to kind of parlay from the cloud to the thing that makes it possible underneath, which is networking technology. Okay, so let's define some things first. So the first thing I want to define is PAN. Okay, PAN stands for Personal Area Network, and that is devices connected around a single person. So give me an example of a personal area network that maybe you put together. Maybe you're working out in Decepio and you have your phone networked to something else. Maybe you have your Fitbit tracker networked to something else. Give me an example. What is the one technology that drives that? Usually these networks are around a person, so they're no bigger than like 10, 15 feet. But it's a network. What's the technology that drives that? What's it called? Bluetooth technology. That's an example of a personal area network. If I am connecting to a printer, you know, through Bluetooth, maybe wireless earbuds, maybe my Fitbit tracker or my smartwatch, that's called a personal area network. We're connecting devices around a single person, right? And those became much more prevalent. Bluetooth is the technology that drives that. The second one you've probably heard about more so far, the LAN. It's called the local area network. A local area network is computers connected at a single site. So a local area network would be if we had a network inside of Schwab Hall and we're all on that network. We're sharing devices, we're sharing printers. That's a local area network. One physical location that the company owns, right? That's a local area network. As opposed to a WAN or a wide area network is when we're connecting between two more separate offices. So let's say we buy Mount Aloysius, okay, which is in Crescent. You guys know where Mount Aloysius is. And we want to have a network where our employees are connecting to it and also their employees are connecting to it. Well, we don't own all the road from Loretto to Crescent, right? So we can't run wires from Loretto to Crescent. We're not allowed to do that. Yes, we're not allowed to do that. Or we bought a school in Ambiolet, France. I guess we do have that. And we can't run wires from Loretto to Ambiolet, France, right? We can't have that. So a wide area network says we want to connect these sites, but we're going to have to use what we call leased lines between those sites. So Comcast, Verizon, AT&T, they do have authority to run lines through disparate sites, right? They're not, you can lease lines from them. Like they already have lines that connect Loretto and Crescent. And you know, a lot of times you see, I don't know if you've ever seen on highways, them putting like between the median, like between like a 4-lane highway, and you know the gap between the 4-way highway. Have you ever seen them digging like a small trench and laying things in that trench? You ever saw that? Like it doesn't look like that's drainage. It's not drainage. It doesn't look like, those are like telecommunication lines. That's to run data far distances. Okay, and that's a wide area network. When I use those kinds of service, when I lease those kinds of lines, that's a wide area network. And finally, the last one is the internet and internets. And you notice it says internet with a capital I and internets with a lowercase I. An internet itself is a network of networks. That's all it is. Okay? It is a network of networks. I could have, maybe I have a network in my house, Maybe my brother has a network in his house and my mother has a network in her house, and I connect those networks together. That's an internet, right? A network of networks. I've connected a bunch of networks together. That is an internet. Why is this one capital? Why is that one capital? Uppercase. Because it is the internet, also known as the public internet, right? So that is only one network. That is the internet. You know what I'm saying? There can be many internets, but the public internet, the one that Amazon's on and you're on and Google's on, is the internet. It is one network, right? It is one internet. Does that make sense? So it's like a person is capital, lowercase p, but we talk about the person or John Miko. It's referring to one thing, so it's uppercase. All right, so let's talk about the technology that makes networks possible. And we're going to talk about a typical small office, home office, local area network. So let's pretend like in Schwab Hall we have a small office, home office area network. So I want to share resources. I want multiple computers, multiple laptops, multiple phones to connect and to be able to share like the printer, the fax machine, maybe we have a media server, all those things. We want to bring those things together. So let's talk about how that happens. Everything on a network, okay, everything that's networked together has to connect to basically, it's like a box. It's called a switch. Okay, let's start there. And a switch has multiple ports on it, and it's kind of like a hub. So when you plug into like an Ethernet jack in your dorm room, you guys ever do that, to plug in Ethernet in your dorm room? What you're actually doing is there's a cable that runs from that Ethernet port to a switch somewhere in your dorm. There's usually a utility closet. You guys know what I'm talking about? It says data closet. Well, there's actually a physical line that runs from that port up through the ceiling tiles into a closet, and it goes into a switch. So it says, hey, room 202 is now physically connected to this local area network. Does that make sense? How about this? So if you don't connect through Ethernet, how else do you connect? So right now, none of you are plugged in, but some of you may be on the network. How are you connected to the network right now? Okay, wireless. So what device do you connect through wirelessly? Not a router. Nope. Router is something a little bit different. Okay. AP stands for access point. Okay, so up here, right above Twitter, is our access point. So right now, what you guys are doing is you are connecting to that access point. And you'll see them in all the rooms in Schwab. There's an access point. And sometimes when we first went wireless on our campus, they didn't have enough access points. So you have no bars, right? You have no Wi-Fi. But right now, all of you guys are connected to that. That still has to get back, though, to the switch. So that access point, which you guys are connecting to wirelessly, actually has a physical connection to that port, that switch, right? One physical connection. So if you think about it, right now, that switch is kind of saying, hey, here's all the things, like everyone gets a connection. All these ports are connections on the switch. When you plug in, you get your own switch. You get your own port. Does that make sense? You're taking a port. Right now, when you guys are all connected to an access point, that access point goes back to one port. You guys are all kind of sharing that port, right? So does it make sense why Wi-Fi is a lot slower than plugging in? Did you ever notice that? Have you ever noticed the speeds are a lot different, right? We're going to talk about that. So when we connect things, we have to connect through a switch. Access points are also connected to that switch. and there are protocols that are used. There are standard protocols. Protocol is the language we use. And the one that we use to connect to a switch, like when we plug in our room, what do we call this cable? What do we call that cable that we use to plug in? What do we call that? What's the word you use for that cable? Starts with an E? It's an Ethernet cable. Ethernet is a protocol, like a language that we connect to, that we can discuss, we can talk with the switch. That language or that protocol is also called 802.3. Okay, 802.3. That's the protocol. That's the standard. It's called Ethernet. So when we're connected to the switch, the language we're using is Ethernet, right? We call it an Ethernet cable. It's not really an Ethernet cable. That's the protocol it's using. It's really just copper wires and stuff like that. But we call it an Ethernet cable. How about when we access our wireless laptop, and we access the access point? You know what standard we're using to connect to that? It's not 802.3. Does anyone know what it is? It's 802 dot something. Ever hear of another 802 dot? Go ahead. Have you ever heard of 802.11? What do we call 802.11? We don't call it Ethernet. What do we call it? What is the name it goes by? Because we don't talk in tech. Wi-Fi, okay? 802.11 is Wi-Fi. So there's different flavors of Wi-Fi. Used to be when it first came out, it was A and B, then there was G, then there was N. The current flavor is something called 802.11 AC. So when my laptop's talking to this access point, it's using the protocol 802.11, and then the access point is converting that through an Ethernet connection back to the switch as 802.3. Okay, so we're talking in 802.11, wireless connections, dotted lines using 802.11, wired connections, solid lines use 802.3. Okay, all those things use 802.3. Now, all this has to come together, and we have to have something on our device that allows me to interface with a network. You have to have some physical hardware that allows me to interface with the network. Does anyone know what that might be called? Ever heard of a NIC? You know what a NIC is? What's a NIC? You know what that is? A NIC stands for a network interface card. And it's actually physical hardware in your device that allows you to connect to the network. So if you want your device to talk in 802.3, it has to have an Ethernet network interface card. Basically, you have to have a port where you can plug in an Ethernet cable and it handles that type of communication, yes? If you want your device to talk in Wi-Fi, it has to have what we call a wireless NIC, a wireless network interface card, and that has to have, right, the ability to communicate via Wi-Fi, 802.11. If your device wants to communicate in Bluetooth, there has to be a Bluetooth network interface card. So if your phone has Bluetooth, it has to have that physical hardware to be able to communicate in that way. Does this make sense? So let's see if we can make sense of this a little bit. I want you to go to your computer, and down here in the bar, just type CMD. CMD. If you can't do it, that's fine. But if I type in CMD, there's a desktop app that says Command Prompt. I want you to click on that, and we go back old school to like the black screen with the white letters, right? This is like the old school interface. And I want you to type into this ipconfig, ipconfig config/all. I think it's / ipconfig/all. And then hit enter. What happened there? You guys with me? Did you get something like this? Nothing like this? All right. So there's a lot in here that beyond the scope of this class. But what I want to show you, this command ipconfig/all says, IP we'll talk about in a minute, like stands for Internet Protocol, and config is obviously configuration. I want to see my current configuration. And the first thing, this is the Windows, let's just put a hold on this for now. But at first thing it says Ethernet adapter Ethernet. So in your computer, there is an Ethernet wireless or an Ethernet network interface card. And it talks about like how it's connected. Yours might say not connected at all because you're using Wi-Fi. I'm not sure, yours might look a little bit different. But a couple things, the description is we're using a Realtek PCIe GB family controller. That's the name of the product, I guess. But it also has a physical address. So it's 18-66DA-004B-AC. Yours is going to have a different physical address, right? You guys look at yours? It's different than mine. I don't know what it is, but it's different. Every network interface card has what's called a MAC address, a machine address, okay? A MAC address, which is unique. So it uniquely identifies, that piece of hardware to the internet. If we go down, okay, a couple other things. That's the tunnel adapter. I don't really care about that. This machine doesn't have Wi-Fi. Yours does. So you probably see, let me see. So you probably see, you see a wireless LAN. You see that wireless LAN adapter? That is your wireless network interface card. And that's probably enabled right now, right? You're probably talking to the internet right now. And it has a physical address as well. So think about how that comes together, right? Inside your machine, you have special devices called network interface cards that allow you to hook into the network, right? Because if you couldn't connect to the network, it's useless, right? It's basically a useless thing. Well, you can do some things with it, but it's basically useless. And you can connect two different ways. And do you have a Bluetooth on there as well? Okay, so you can connect three different ways, right? To three different networks. You can connect to an Ethernet network through your Ethernet cable. You can connect through Wi-Fi. And because they're Bluetooth capable, you can connect through Bluetooth. So that means there's hardware in your device that says, here are the things that I can interface with, right? It's almost as if you could speak three different languages. I can speak English, I can speak Portuguese, and I can speak Russian, right? I can communicate to the network of Russian individuals, English-speaking individuals, and Portuguese-speaking individuals. That's what that is allowing you to do, right? Because the network is the key. Does this make sense? Okay. So let's go back then. Let's go back to this slide, because this has a lot of things on it, and hopefully I don't miss anything. So all these things are hooked together through this switch, which is great. A switch is an internal thing, however. So it's an internal thing. It's something on our campus to hook you guys together, and so that you can, so that we don't have to go out to the internet if we're just communicating in-house. We're connecting to a printer here. Well, hell, I don't want to go out to the internet to attach to that printer. I want to go through our local network. However, for many things, including the cloud, I want to go out, right? I want to go out to the internet. There is something known as an internet service provider. We're going to talk a little bit about that. I just talked about our internet service provider at St. Francis University is Comcast, and it's a little different than what would be at your personal space. How about at home? How do you connect the internet at home, though? Verizon. So is that DSL probably, right? Anyone use cable? Anyone use Comcast or Atlantic Broadband to connect? You do, Danielle? Okay. So that's your internet service provider, okay? So at St. Francis, our internet service provider is Comcast. Now, so let's go back to that command prompt. I know I'm skipping ahead here, but let's go back to that command prompt. And I'm going to do this, okay? So my device here is connected through Ethernet to a switch somewhere at St. Francis, yes? I want to go out and go to a website and, I don't know if this is going to work, but let me try this. Trace. So I type tracertportageball.com, and hopefully this works, okay? So portageball.com is a website I run for youth sports in the Portage area. And what it's trying to show me, okay, is how I get from my computer to wherever the hell portageball.com is. Portageball.com is the domain name that we use. That's the human-friendly address of portageball.com. But if I go into, let's write that down, 209.197.85.142. So if I go to a browser and I type portageball.com, it is going out through our internet service provider, connecting to the server, which I think is in Pittsburgh, okay? If I just type in, instead of portageball.com, I type in 209.197.85.142, that is the IP address of that computer somewhere, right? That is the actual address. We use portageball.com because we don't want to use what is using behind the scenes. But that's why we see, when I ran that trace route, we see that it says, oh, you want us to hook up to portageball.com. My address, my internal address for that, I don't use portageball.com. That's just a human-friendly name. I use the IP address 209.197.85.142. Here's what it does, okay? It starts with my internal machine, goes probably to a server somewhere at St. Francis. Now it's connecting to some kind of server, another server at St. Francis. ACUP is the Association of Colleges and Universities in Pennsylvania. I think we pool our resources with them. So we serve like with us, and I think it's like St. Vincent's, and we kind of come together and say we can get a better price if we come together. So that's why it says ACUP. And then we end up in Pittsburgh, it looks like. Okay, so I think this server is in Pittsburgh. If this server were in California, you would see it would start at St. Francis. It'd probably go to Chicago next. Then it would go to maybe Colorado, and then maybe the next hop would end up in California. So think about it. In our network, you know, we are saying, go back to this thing, all this stuff, okay, all this stuff is internal, but when we want to go outside of St. Francis, we use Comcast, and we go through what is called the public internet. Okay? All those hops with the public internet. This is a lot to bring together, and I'm not sure I did it real well today. I gave you a lot of things. We're going to spend some more time kind of fleshing this out because there is a lot going on, and it's amazing. It's truthfully amazing, right? Like when people first invented fire, they thought, that's amazing. But it's amazing that you can send an email to someone in China, and if you're on the phone with them, you're upset if like in 5 seconds you don't get it. You didn't get it yet? What the hell's going on? Right? Think about that. It is amazing. You can stream video from some server where you don't know where the hell it is, but it's probably in the central part of the United States, you know, and just see it on your screen. It's amazing. All right, so I will see you guys on Friday. We'll talk more about the cloud and networks.